Hello there, and welcome to day 68 of the 100 Days Python Programming Challenge. Yesterday, I introduced you to Numpy. Today, let's go a step further. So today is Numpy Part 2. So what would I be talking about today? I would show you how you can reshape arrays, how you can perform broadcasting, how you can also do stacking and splitting, and so many more. So today is Numpy Part 2, and my name is Fumi from Beth Media. Hello there, and welcome to day 68. I'm like so happy every day that we continue. It's day 68. Yesterday's day 67. I introduced you to NumPy, and this, if you have not watched the video, I highly suggest you go watch day 67 video. Today, we're still talking about NumPy, and I'm going to show you other things that you can do with NumPy. So the first thing that we will do is reshaping, and then we'll do broadcasting, multiplication, sorting, and so on and so forth. So what do I mean by reshaping? Imagine you have a one-dimensional array and you want to convert it to a two-dimensional. You want to define the number of rows and columns that you want to reshape it to from that particular one-dimensional array. What we'll do is to use the reshape function. So first, let me have my two arrays. So I want to have my first array to be a range from the number 1 to 13. That means I want number 1 to 12. So this is how we do range. Remember yesterday when we spoke about range? Yeah, range of values. So I want my range to be from 1 to 13, and that will be my first array. If I print out just array 1D, you see, I have my array from 1 to 12. So I have my first array. And then my second array will then be my new array that I want to reshape. So I want to have these numbers in 3 rows and 4 columns. So then my second array would then be array 1D dot reshape in brackets 3 rows and 4 columns, because that is what I want. So I want to convert this. This we have 1 row and we have 12 columns. I want to convert it into 3 rows and 4 columns. So let me now show you the result. So this is our original array, and when we reshaped it, it picks it 1, 2, 3, 4. That is my first row. 5, 6, 7, 8. That's my second row, and 9, 10, 11, 12. That is my third row. So this is how we're able to reshape our array from one dimension to a two-dimensional array. So then, what if you now want to convert it back? You want to convert the array 2D back to your array 1D. We use something called the ravel method. The ravel then flattens the multi-dimensional array into a single dimensional array. So it's the same thing, the way we did array 1D, then reshape, and then we have array 2D ravel. And then when I run this, we get our flattened array back. So this is how we're able to convert a single dimensional array to a multi-dimensional array by using the reshape. We specified the number of the rows and columns that we wanted. And then to then change it back to get our original array, or maybe you have a multi-dimensional array that you want to flatten into a one-dimensional array, then you use the ravel method. So reshape and ravel. That is what you use for reshaping arrays. The next thing that we'll talk about is broadcasting. What is broadcasting? Broadcasting is a feature that allows arrays with different shapes to be combined in an arithmetic operation. So you might have like a multi-dimensional array and a single dimensional array, and then you want to combine both, but you want to use arithmetic operation. That is by using, maybe, or you want to add them, you want to subtract from each other, or you want to multiply, and so on and so forth. So it is a way of vectorizing array operation so that loops are avoided, and this leads to faster execution. So now to my example. I have a multi-dimensional array and I have a one-dimensional array, and then I want to combine both by using addition. So I want to add both together. Let me show you my arrays first. These are my arrays. And you see this is multidimensional and this is a 1D array. So I want to add both of them together. I want to combine them. So I would have my result is equal to matrix plus row. So this would add 10, 20, and 30 to the respective columns in my matrix. And when we have the result, first I want to print out my original matrix so you can see it. I want to print out the row that I'm adding, and I want to print out my result. So when I run this, we have the original matrix, which is 1, 2, 3, then 4, 5, 6, and 7, 8, 9. This is the row that I want to add to it, and then my result after broadcasting. So you see 10 was added to 1, it was added to 4, it was added to 7, 20 was added to 2, 5, and 8, and 30 was added to 3, 6, and 9. So they were added to their respective column. So broadcasting, you're adding array or combining array using arithmetic operations. Multiple arrays, you want to combine them together using arithmetic operation. Next, we move to matrix multiplication. So we can have like element-wise multiplication or matrix multiplication. If you don't know, then now you know. So we have two arrays and we want to multiply them together. So let me show you my two arrays. I have arrays of 1 and 2, 3 and 4. That's my first array. And then my second array is 5 and 6 and 7 and 8. So this is my first array and I want to perform element-wise multiplication. Element-wise multiplication is just A multiplied by B, A asterisk B. And then when we have the result, what will the result be? The result will be 1 times 5, that is 5, so that will be the first entry. 2 times 6, that is 12. And then goes on and goes. Here we have like 2 by 2 array, 2 rows and 2 columns in our A and B. So when we multiply them together, the result will still be a 2 by 2 array. And here we have the result. So we have 1 multiplied by 5 is 5, 2 multiplied by 6 is 12, 3 multiplied by 7 is 21, 8 multiplied by 4 is 32. So this is how we do element-wise array. We have two arrays and then we multiply them together. They are the same rows and column, so the result will be also the same rows and column. But what if we now have the matrix multiplication? Let me show you. Here we use A asterisk B. For the matrix multiplication, we'll use NP dot A and B. So this is how we want to do matrix multiplication. NP dot dot first dot A and B. And then when I print out the result. So what did we do with our NP dot A and B? We performed matrix multiplication. So that is, we took our 1 multiplied by 5 plus our 2 multiplied by 7, and then we got 19, and then we took our 1 multiplied by 6 and then 2 multiplied by 8. So that is how we're able to perform matrix multiplication. If you're wondering that what is now the difference between the element-wise and the matrix multiplication, for the element-wise, it multiplies the corresponding element, while for the matrix multiplication, it performs a dot product of the rows and columns. And then for element-wise, the operator is this asterisk, while for the matrix multiplication, we use the dot. And then it is used in element-wise transformation, while this is used in linear algebra computation. So this is how we're able to perform matrix element-wise multiplication and matrix multiplication. The next thing that we'll talk about is sorting and stacking. So you have your array and then you want to sort it in ascending order. So I have a one-dimensional array that is not properly sorted. So this is my 1D array. And then to sort my array, I would use the sort function, the np.sort. So I'll have sorted array equals to np.sort. And what am I sorting? I'm sorting my array. And then when I print out my result, which is the sorted array, these should be sorted. So 5 should come first, then 10, then 20, then 25, and then 35. So this is my sorted array. I run this, we have a perfectly sorted array. Then what about searching? You're still using the same array. Imagine I want to search for numbers that are greater than 15. Or you can search for whatever you want, but yeah, we want to search for numbers that are greater than 15. So yeah, we have that 25 on index 0 is greater than 15. 35 on index 2, 0, 1, 2 is greater than 15. 5 is not. And then 20, our final index 4, is also greater than 15. So what do we use when we want to find elements, when we want to search through element? We would use the np.where, and in brackets we'll put our condition. And what is our condition? We want to search in the array for numbers that are greater than 15. So I would have array greater than 15. So indices is np.where helps you to find element that satisfies a condition. And then when we print out our indices, again, it will only print out the index of the number, the position of the number in the array. So instead of it printing out 25, 30, and 20, it lets us know what position 25, 35, and 20 is. So we would have 0, 2, and 4. So these are the places where we have the numbers that are greater than 15. And next we have our stacking and splitting. Stacking is just, you can have vertical stacking, you can have horizontal stacking. So vertical stacking is vertical, I'm putting your array on top of each other, while horizontal is just like converting it to a 1D array, making it horizontal. So vertical, they are stacked vertically, horizontally, they are stacked horizontally. And we use the V stack to stack them vertically, and we have the H stack. It's even so easy. V, vertical stacking, H, horizontal stacking. So let's have our two arrays that we want to perform this stacking function on. You can try it with different arrays, put like different numbers so you can see how it looks like when you have like multi-dimension, different rows and columns, just to practice. So to stack my array, I will use np.vstack, that is when performing a vertical stacking. And in brackets, what do I want to stack? I want to stack my A and B. So vstack is then equal to np.vstack, and what I'm stacking, A and B. So this is the syntax for it, np vstack A and B. And when I run this, they are vertically stacked, combined together, vertically stacked. Then what if I want to do the horizontal stacking? It's exactly the same process, just that instead of V stack, I would then use the H stack, like we said, V stack, H stack. So now for my H stack, it is going to stack them, or instead of putting them on top of each other, it's just going to put them side by side, stack them together. Put them together. So that when I run this, we have our horizontal stack. Vertical stack on top of each other, separated in different lists. Horizontal stack combines them together. Then we have splitting. What is splitting, you might ask? Splitting is that I want to divide an array. I want to divide it. So I have like for example, my horizontal stacked array, or any one-dimensional array that you have, and then you want to divide it. You have to specify how many divisions do you want. Like you have this, for example, there are 6 elements in your arrays. You may want to divide them into 3. So that means you would have 3 arrays. So you have 1 and 2 in one, 3 and 4 in another, and 5 and 6 in the third one. So you specify how many arrays do you want to get while you're splitting. So using my horizontal stacked array, I want to divide them into 3 arrays. So I have my split array and it's np.split, np.vstack for vertical stacking, np.hstack for horizontal stacking, np.split for splitting my array. And what am I splitting? I'm splitting my h stacked, the variable that I defined there. So my h stack, and how many arrays do I want to split it into? I want to split it into 2. And when I run this, we have our array splitted into 2. If you change this to 3, and then when you run this, you have your array splitted into 3. So these are the stuff that we've talked about today. We talked about how you can reshape your array, how you can flatten your array, how you can perform broadcasting, element-wise multiplication and matrix multiplication, sorting and stacking and splitting and searching, and so on and so forth. So they are practice questions for you to try, and I'll see you tomorrow for day 69. That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions, and as always, the link to the Jupyter notebook is in the description. See you tomorrow.